Hello guys, so we are back again, and in this session we are going to do comprehension type questions of Singlish. Okay, so we have completed single correct, okay, multiple correct option questions, and lastly we are going to start with comprehension. Then we will move on to numericals. We don't do matrix type problems, and then we will move to inequalities. We will complete the previous year question. We will take the previous year question in the end. Okay, so the first comprehension. Okay, uh, question. Okay, so the first comprehension. Okay, this is the first comprehension one, which says sum of a certain consecutive odd positive integers, okay, is 57 square minus 13 square. Then number of integers are, okay, it is firstly asking number of integers are, okay. So the so it is telling that certain consecutive odd integers, okay. So we can consider, let the odd integers, okay, integers be. Now what common mistakes which children do, they take common means odd integers like 1 3 5 like this, okay, and 2 and minus 1, which is wrong, because here they have told sum of certain odd positive, not from starting from this two, okay. So we have to take any general. So can we take this one, 2n minus 1, 2n minus 3, 2n minus 5, and so on, okay. But if you observe, it is a decreasing, okay, it is a decreasing AP, okay. Odd numbers means they will surely be in AP, and it is a decreasing AP, okay. And until and unless it is not mentioned, we should not take a decreasing GP, decreasing AP, okay. So we will reject this one also, okay. And lastly it will move on, and the final term will be, okay, we don't consider the final term. This is the pattern, okay. Here we will put one, we will get one, but the problem is it is a decreasing, okay. And they means in their problems, until they mention never take decreasing GP, so we are not going to consider it, okay. Now the last option is considering the terms like this, okay, 2n plus 1, 2n plus 2, 3, 2n plus 5. Is this method right? It first, its D is what? Its D is 2, which is positive, while its D was what? Minus 2, which is negative, okay. So the decreasing GP, and we take until unless mentioned, we take increasing GP AP. So this one is right. First thing is confirm how, why we are considering these terms, 2n plus 1, 2n plus 3, 2n plus 5, okay. So hope you have understand the idea of considering these terms, 2n plus 1, 2n plus 3, 2n plus 5, okay, these terms, okay. So we got idea, it is in AP, they will be in AP. It is a very general, okay, anybody knows it, okay. Odd terms and even terms, they are in AP, okay, no matter what, okay. And it also satisfy if you put here any, if you take here 5, here take here 6, it will take 7, then the terms will again be, no matter from where you target, okay, odd terms, okay. If there is a set of odd terms, if you target this sector, okay, this part, okay. If I say there is 1 3 5, okay, 7 9, okay, 11, and so on. If you say no, I will not take this, I will take this, so you have to substitute 4 5 6, okay. This set will form consecutive integer set, okay, fine. So this set has no issue, fine. So now what we can do, it is telling sum of certain consecutive integers, okay. Now we are taking a set, so it would surely have n terms, okay, have n terms, okay. This is very general, anybody knows. If you consider n terms, a plus d, a plus 2d, it will go until n term, okay. So it will have n terms, that is very general. Now they are telling sum of term is minus 13 square, but we already have the sum of the term formula, okay. So we already have the sum formula, okay. N by 2 bracket 2 a, okay, we are doing a mistake, n is appearing here and here also. So we will consider terms like this, 2p plus 1, 2p plus 3, okay. So here we are taking 2p plus 3, 2p plus 5, and so on, okay. Just forget this one, here n is there, okay. So my first term will be 2 into a, which is first term is what, 2p plus 1 plus n minus 1, n terms are there, into d is what 2, as I have told you. Then what it will become, n into 2p plus 1. Okay, I am taking multiplying 2 inside, which will give me n minus 1. Okay, I am left with this thing. This n minus 1 with plus 1 will cancel to give me 2p plus n. Finally we are left with 2np plus n square. Okay, and here we have 57 square minus 13 square. Hope till now you have understand our answer, which we will get by comparing only. Okay, so how we can compare? Here there is no square. Okay, negative and square. Okay, to make this square, okay, sorry, this is second and third part of this. Okay, to make that we will do a thing, that is, if I add here p square and minus p square, then what I get, if you observe, this is nothing but p plus n the whole square, and this is nothing but p square, and here again 57 square minus 13 square. So you must understand where you have to do the manipulation. Okay, here you must understand that we have to add p square minus p square. That is a good part, that is a sign of good student. Okay, that you analyze. Okay, we cannot compare this with this. Okay, to make it perfect square, okay, we know only one thing, to make a perfect square, so we added p square on and subtracted, so which made it a perfect square, and then we compared it. Okay, so by comparing we got one thing, that p plus n is nothing but 57. Okay, p plus n is nothing but 57, and what we get, and p is equals to nothing but 13. So what we get from here, if I substitute 13, 13 plus n is equals to 57, which gives me n is equals to 44. Okay, so I got, what was our p was nothing but the position, okay, which was giving us, okay, the odd positions. Okay, odd positions, and n is total number of terms, okay, consecutive terms. Okay, so p1, p2, p3 to p13. Okay, p13, the value of p is 13. Okay, so what we can do after this, what we can do, okay, we got the p value. Okay, so we got the odd integers. We consider this, if I substitute 13 here and 3 here, okay, 13 here. Okay, we analyze which set of odd integers they are targeting, whose sum we are getting this. So p is equals to 13. If I 13 here, 13 here, 13 here, then we get a set of odd, that sum is equals to this. Okay, that is what they are meaning. Okay, further on we got the total number of elements in this set. Okay, now let's see the questions. Number of integers are, okay, number of integers are n is equals to 44 is number of integers, so third is the answer. Okay, number of integers. Sometimes some passages are like this, that if you solve them you will automatically get sometimes you get the answers. Okay, the least value of integer is, okay, how we can get the least value of integer. Okay, we considered the starting integer at 2p plus 1. Okay, and we know the set, okay, p value, p is what, p is 13. So the starting it is 2p plus 1. If I substitute here 13 plus 1, what I get, 26 plus 1, which is nothing but 27. Okay, which is nothing but this, so we are getting 27. So the least value is nothing but 27. Okay, second option is the correct. Now let's check for the third. The third is telling the greatest integer is divisible. Okay, divisible by 7, divisible by 11, divisible by 9, and none of this. Okay, none of this. So how we can identify it is, so we have to find the greatest integer. Okay, for that what we can do, okay, to find the greatest integer we can do one thing. We want to find the last term tn. A plus a is what, the first term we have already found, 27, plus n is nothing but 44 minus 1 total number of terms into d is what, 2. So can we get the tn? Yes, we can get 27 plus 43 into 2, okay, which gives us what, 27 plus this is 8 and 26, okay, 86, which is nothing but 113. So is 113 divisible by 7? No, it is not divisible. Is divisible by 11? No, it is not divisible by. It is divisible by 9? No, it isn't. So 4 means none of this is the correct option. So 4 is the answer. Okay, so we are done with this first passage. Okay, hope you have understand each process, what we did in the starting, how we consider this term only, why many children consider this term and get wrong answer, why we consider this term, okay, that is also a wrong idea, why we do that, okay, why to avoid that, because it can be any consecutive from any set. Okay, and what was the reason behind considering this term, then getting the sum formula, what was the reason, why was we getting some p value, because we were targeting a certain set of odd positive integers whose sum was this. Okay, then getting the sum. Okay, all the things you should be very fixed in your mind when you solve, okay, this type of question, passage type question. Okay, now let's move on to the next question. Okay, we have done this passage one. Okay, now let's move on to the passage two. Okay, sorry for my pages fault. Okay, now let's move on to the second question, the second comprehension. Let me get the three questions of the second comprehension. Okay, the second comprehension is as follow. Let's read the second comprehension. We said consider three distinct real numbers a comma b comma c in a GP with a square plus b square plus c square is equals to t square, and a plus b plus c is equals to alpha times t. The sum of the common ratio and its reciprocal is denoted by s. Okay, first complete set of alpha square. Now alpha square, by hearing alpha square, okay, the options are 1 by 3 into 3, some included 1 by 3 3. Okay, this was means close bracket, nothing but 1 by 3 to 3, 1 excluded, and minus infinity to 1 by 3 union 3 to infinity. Now what when they meant by alpha square, okay, alpha square means we want to alpha square, we have to square it. Okay, and to get alpha square it will become t square, so we can divide and get the answer. Okay, and these terms are in GP. Okay, that is also a good advantage. Okay, sum of the common ratio and its reciprocal. Okay, now let's first understand what they're giving. They're telling that a b c are in GP. So can I write a is equals to a, b is equals to ar, c is equals to ar square. Okay, very general thing. Now they are telling that the sum of common ratio means, if I say let r be common ratio, okay, let r be common ratio, then that s is nothing but r plus 1 upon r. Sum of the common ratio is nothing but sum of the common ratio, okay, and its reciprocal is denoted by s. Okay, this, okay, not sum, it is denoted by this s. Okay, now what we can do, okay, what we can do okay, let's begin with the solution. Okay, so first idea was squaring. Okay, so first doubt many children have, okay, that should we square this? Why you should square this? Because you want to find alpha square. Is there any alpha square here? No, there is no alpha square, so there is no reason to square it. Okay, so we will not square it, we will leave it only. Okay, b plus c is equals to alpha times, will we square this? Yes, we will square it. Why square it? Because then only we will get alpha square. So a plus b plus c the whole square is equals to alpha square into t square. Now you will say a plus b the whole square formula we don't remember. Okay, don't get in hurry to substitute and break, means expand the things. Okay, try to be patient and try to solve this question, because it is in GP. There is high probability of getting the terms cancelled. So why expand the things, okay, unnecessarily, until you get the particular means, until you get into a situation there where there is no other option other than substituting. Okay, so what was our process? We were going to divide alpha into t square by t square. That was our main purpose. This was what? A plus b plus c the whole square, and this was what? A square plus b square plus c square. Fine. So t square will cancel out, giving me alpha square is equals to, here a was a, I can substitute b as ar, c as ar square, and this is whole r square, giving me a square r square. Fine, a square r raised to 4, because it is a r square. Okay, so I can write this. Further on, here I can take a common from both the side, it will be nothing but a square only. So what I'm left with, 1 plus r square the whole square into 1 plus r square plus r raised to 4. Okay, now here the children who don't know a basic thing which we discussed, okay, which I told in the lectures on the sequence series, okay, and which we used in quadratic also, if they don't know that thing, then they have to do the expansion and solve it. If you know the basic fact that r raised to 4 plus r square plus 1 can be written as r square minus r plus 1 into r square plus r plus 1, then your question will simplify. It will be nothing but r plus r square plus 1, okay, into r square plus r plus 1. This written twice, this I can write r square plus r plus 1 into r square minus r plus 1. Okay, very simple. This will cancel out, giving me finally r square plus r plus 1 upon r square minus r plus 1. Okay, this much is very easy. Okay, now after this what we can do, after this we will apply the always remember when you get something like this, okay, try to remember your quadratic concepts, because there were some things which you had taught, like let alpha square be m. Okay, let's take alpha square is equals to m. If I take m, then it will be m into r square minus r plus 1. I did nothing, just cross multiplied the things. Okay, we always apply when I get 2 quadratic upon quadratic into some y, we always cross multiply and apply d greater than equal to 0, because it is only possible if r is greater than equal to 0, r is real. Okay, so always try apply that condition. Okay, there is means it is very general, we have done so many problems on that. Okay, after this m plus 1 into r plus m minus 1 should be equal to 0 if for r real. Okay, d should be greater than equal to 0. If I apply that, m plus 1 the whole square minus 4 m minus 1 the whole square, giving me finally m square plus 2m plus 1 minus 4 m square minus 2m plus 1 should be what, greater than equal to 0. Okay, which will give me greater than equal to 0, which will give me what, here minus 3m square, it will become 8. Okay, 8 plus 8, then it will become 10m, and this will become minus 4. Okay, minus 4 plus 3 minus 3. Okay, minus 3 greater than equal to 0. I will make this term positive. Okay, always quadratic first term is positive, so this will become negative. 10m plus 3 should be less than equal to 0. Now I will find the m value. How? Minus into minus 10 plus minus under root 100 minus 4 3 into 3. Okay, upon 2 into 3, which will give me 10 plus minus upon 100 minus 4 3 is 12 is 36 upon 2 means 6. Okay, there was no need of finding it here. Okay, it is very simple, we can get it by simple method, that 9m. Okay, this v plus m plus 3 should be less than equal to 0. Okay, if I take 3m common, m minus 3 minus 1 into m minus 3 is less than equal to 0. Okay, is less than equal to 0, we are left with m minus 3 into 3m minus 1 less than equal to 0. Okay, so finally if I plot the wavy curve, what I am getting, 1 by 3 upon 3. Okay, positive, negative, positive. Okay, so my final answer which is coming is this 1 by 3. Okay, it is less than equal to, so it will be always be included. Okay, so one more thing, now many children which forget that they got this answer from quadratic. Okay, so in quadratic the first term should always be positive, it cannot be 0. Okay, so if m is equals to 1, then it will become 0. Okay, which should not be, so we will exclude the 1. Now we will do what, we will substitute the m is equals to 1 by 3 in place of alpha and check, because in GP there was one issue, and if you remember that issue, then you will understand why I am doing this process. Otherwise, after simplifying, then I will tell you what was the reason for doing this process. Now, okay, I will substitute, put m is equals to 1 by 3. Okay, now where to put? Okay, although if you understand, if you are means you must have understand where to substitute. We will substitute here, because m, we have taken m this value. Okay, we have taken m as alpha square, so we will substitute here only. So m is equals to what, alpha square plus r plus 1 r square minus r plus 1, so it is 1 by 3, so it will become r square minus r plus 1 is equals to 3r square plus 3r plus 1, giving me finally 2r square plus 4r equals to 0, giving me okay, there will be one issue, this will be 3. Okay, this will be 3, so it will become minus. Okay, this will become okay, let me understand, this will be 3. Okay, this will be 3, and here it will be 3, then it will move on that side. Okay, which will give me r square plus 3. Okay, so we will take plus 3 will be there only. Okay, 2r square plus 4r. Okay, plus 3. Okay, plus 3, right, this will be plus 3. Okay, r square minus r plus 1, this will go that. Okay, plus 4r plus 3 should be equal to 0. Okay, which is giving me finally, okay, this will be 3 and 3 minus 1 will be 2, sorry, this will be 2. Okay, so if I subtract divide by by 2, we get 2r plus 1 should be equal to 0, and it makes you realize that this is nothing but r plus 1 the whole square is equals to 0, which gives r is equals to minus 1. Okay, now just be little cautious, okay, and just think again. Means what means till now what you have done. Okay, if you remember, if I have taken the terms a b r a c r, if I put r is equals to what, r is equals to what I should put, I will put this. Okay, let me don't take this page. Okay, these are second and third question. Okay, so if I put r is equals to what, minus 1, if I put r is equals to minus 1, then this is a, this is minus a, and this is a. So is this a GP? No longer, this is not a GP, so can we consider r is equals to minus 1? So when r is equals to minus 1 appears, when I consider m is equals to 1 by 3. Okay, now we will check for m is equals to 3. I will sub this will 3 square minus 3r plus 3 should be equal to r square plus r plus 1. This will become 2r square, this will become minus 4r, this will become plus 2. Again you are saying the same thing. Okay, but this time r minus 1 the whole square is equals to 0, r is equals to 1. Again, if 1 is substituted, this will be nothing but 1, e and a, all the terms. This is not a GP. Again, so r is equals to 1, not acceptable. Why r is equals to 1 appearing? Because m is equals to 3 is considered in the set, so we have to remove m is equals to 3. So our final answer means our final set will have what, m belongs to not 1 by 3, not 3, and excluded 1. Okay, so the set of values is nothing but 1 by 3 and excluded 1. Okay, hope you have understand. I tried my best effort to make you understand, okay, each and every step why we consider terms, okay, all the given conditions. Okay, hope you have understand how I got this set, what was the reason of rejecting 1 by 3, and why we rejected 1. Okay, because okay, so hope you have understand the reason for rejecting 1 by 3. Okay, all these steps clear. Why we did the delta, okay, d greater than equal to 0, and okay, I told the reason behind I multiplied this and got these values. Okay, why I break this? Okay, because I have told all the things in the when I was explaining the chapter only. Okay, so now let's take the second question of this comprehension. Okay, which says this. The second question says complete set of S is what? Okay, so we already know S is nothing but r plus 1 by r. Okay, now if I do one thing, I cross multiply r square 1 by, okay, this will become r, this will be s, this will become r into s is equals to r square plus 1. Okay, so r, we multiplied this r into s is equals to r square plus 1, so we are getting r square minus r into s plus 1 is equals to 0. Okay, so what what we can do, that r square, we formed a quadratic equation. Okay, here because the condition given, okay, was r is equal, s is equals to r plus 1 by r. Okay, now it is a quadratic. Okay, and r is real, as we told, r is real, so we can apply d greater than equal to 0. Okay, so whenever there is like this, okay, I will tell you one more hint. Okay, but if you have done quadratic equation, you will already understand that whenever this type of range type answer appears, they mostly appear from applying d greater than equal to 0 in any equation, because okay, in sequence series number should be real. Okay, the set means the domain is real numbers. Okay, so these answers mostly appear due to d greater than equal to 0. Okay, so I have told you this reason also, the purpose of doing d greater than equal to 0 again and again. So if I do this, this is what, r square minus 4 into 1, which is giving me, okay, sorry, this will be s square. Okay, then should be greater than equal to 0, giving me s minus 2. This will be nothing but a into a square minus b square, s and s plus 2 greater than equal to 0, giving me s. Okay, now if I plot a wavy curve, okay, minus 2, we want to consider, okay, we want to consider what values? We want to consider positive, negative, positive values. So x belongs to, okay, s belongs to what? S belongs to minus infinity to minus 2 union 2 to infinity. Okay, now we will reject what values? We will reject minus 2 and 2 values. Again the same reason, they will if I take those values, it will no longer be a GP. Okay, again, so for that reason we will reject these values. Okay, so our final answer, okay, is nothing but minus s minus 2 union 2 to infinity. Okay, okay, so sorry, the d will be what? Greater than 0. Okay, d will be greater than 0. Okay, d will be greater than 0 because, okay, we are considering whole set. Okay, okay, so it will not be greater than always equal to 0. It will be greater than, okay, there are two conditions. Okay, when we were teaching quadratic, okay, one was d greater than and d greater than equal to 0. I told you the conditions. Okay, okay, when they ask for a complete set, okay, they include positive and negative both the, okay, then we applied d greater than 0. Okay, so we applied here and then we are going to get this equation. Okay, although you will get the same answer from d greater than equal to 0, many teachers don't tell, okay, the difference between d greater than equal to 0 and d less than 0. We have discussed it in detail in quadratic equation. Okay, so you must if you even do this thing, okay, this is the mistake of d greater than equal to 0, you can verify from the equation. Okay, not an issue. Okay, your final answer will be s belonging to minus infinity minus 2 union 2 to infinity, which is nothing but, okay, this one. Now let's, okay, move on to the third question. Okay, the third question, okay, the third question is this. Okay, sorry, I have taken the previous question only. Where is the third question? Yeah, where is the third question? Third question, I'm not getting the third question. Okay, the third question is this. Okay, this is the third question. Okay, the third question says if a comma b and c also represent the sides of a triangle, then the complete set of alpha square is, okay, so complete set of alpha square they are asking. Now the sides are what? ar square. Okay, so if I consider case 1, okay, how there can be three cases. First, a plus ar is greater than ar square. First case, so here 1 plus r is greater than r square, which will give me r square minus r minus 1 is less than 0. Okay, is less than 0, which will, if I try to find the x r value, which will be nothing but 1 plus minus under root 1 minus plus 4 upon 2, which will be nothing but 1 plus minus under root 5 by 2. Okay, now since it is the sides of triangle, r will be what? Greater than 0, so we will include only 1 plus under root 5 by 2. Okay, so we are going to get this value. Okay, okay, this will also be positive. Under root 5 value is more than 1. Okay, okay, so we can include both the values because 1 minus under root 5 by 2, okay, it is also positive, so 1 minus under root 5 by 2 is also included. Okay, so we are getting 1 minus under root 5 by 2 as one value, and r is equals to 1 plus under root 5 by 2 as one value. So okay, so if I draw the wavy curve, 1 minus under root 5 by 2, 1 plus under root 5 by 2, positive, negative, positive, so we will include r belongs to what? 1 minus under root 5 by 2, 1 plus under root 5 by 2. Okay, so we got one value. Now case 2. Case 2 is what? A plus if I consider this side, ar square is greater than ar. Okay, 1 plus r square greater than r, giving me r square minus r plus 1 is greater than 0. Okay, if I find the r value, here I will have 1 plus minus under root 1 minus 4 upon 2 into 1. Okay, and this value will automatically rejected because it is what? Negative. F of x greater than 0. Okay, it also gives you a hint, okay, that t will be what? Less than 0, so it is negative, so we will reject the case 2. Finally we will move on. Okay, I'm using this page. Okay, we will move on this page. Okay, here we consider case 3. Okay, case 3, which will be what? Okay, so we will consider the case 3. Okay, now let's see what cases we have considered. The cases which we have considered, okay, the first was a plus ar, a plus r square. Now we can consider a r square, ar square. Okay, ar square plus ar is greater than a. This will give me r square plus r minus 1 is greater than 0. and here if I found the r value -1 plus minus under root 1 minus 4 into -1 upon 2, which will give me -1 plus minus 5 upon 2. So here we are going to get, okay, we are going to get some what value here. -1 will be rejected, the only one will be included will be -1 plus under root 5 by 2. Okay, this one will be included. Okay, if you observe, okay, okay, this one will be positive. So we got two sets. Okay, now wait, positive negative. If I bring the series, this is -1 plus minus under root 5. Okay, -1 upon 2 into -1 plus under root 5 by 2. I want positive, negative, positive. Okay, but r is greater than 0, so the only one included will be under root 5 by 2 to infinity. Okay, now we got one this, and the second which was valid was from this one, which was what, from where, okay, from where it was, which it came was from this one. Okay, -5. Okay, it is also negative. Okay, so sorry, this one is negative, so the final answer will belong to what, 1 plus under root 5 to 2 to infinity. Okay, when we take union, okay, of 1 and 2, this is, sorry, this is 1 and this is 2. Okay, okay, so if I take the union, okay, the common r value which can be possible, okay, okay, this should be okay, this should be -1 minus under root 5. It will not be, okay, it will be plus 5 under root. Okay, -1 plus 5 under root. Okay, so the r value will belong from what, minus, okay, -1, okay, will belong from what, minus, okay, if I take the possible values, okay, the one is 1 plus -1 plus 5 upon 2, okay, to under root 5 plus 1 upon 2. And now we will not include 1, because if I include 1, it will no longer be a GP. Okay, I did a mini mistake. Okay, did any mistake? R plus minus 5 upon 1 plus minus 5 upon 1 minus under 5 by 2, r is equals to, okay, okay, we included this set. Okay, and if I take the intersection, okay, if I take the intersection, okay, of these two, okay, there was, okay, although this answer was wrong, we will do what, we will not take intersection of this. Okay, we will not do the modification of this. Okay, the answer should be from 1 plus 1 from 5 by 2 to infinity. Okay, that is wrong. We will take here, it will be minus infinity to this -1 minus under root 5 by 2 union -1 plus under root 5 by 2 to infinity. Okay, then we will take intersection of these two. Okay, because between two sets we take intersection. Okay, then we will take intersection and between cases. Okay, then we will take intersection. Okay, so it will give us what, our final answer will be r belongs to -1 by under root 5 by 2 to under root 5 plus 1 by 2, 1 excluded. Okay, because if I include 1, it will no longer be a GP only. Okay, now what we can do, we can do one thing. Okay, if I observe alpha square, okay, it was nothing but r square plus r plus 1 upon r square minus r plus 1. If I do one thing, r square plus r plus 1 minus r upon r square minus r plus 1, we will get 1 plus 2r. Okay, we have to add 1r and subtract, this will be 2r upon r square minus r plus 1. Okay, don't you agree with this? Then we will left with 1 upon 2r upon, okay, sorry, so the r value is satisfied by this also. Okay, this function will also have the same, okay, same domain like this where it belongs. Okay, okay, the answer, if I add that set plus 1, I will get alpha square nu, so the possible will be greater than this one and between this. Okay, so what can be the possible answer? I have r belonging to -1 plus under root 5 by 2 to under root 5 plus 1 by 2. Okay, so first 1 by 3 to 3. Okay, okay, first thing, it cannot be 1. Okay, and this one is 0 included, so it is rejected. 2 comma 3, not possible. Okay, because this is what, 2 plus 3 between 2. Okay, this is 2 and this number will be after after 1 means after 1. Okay, so this one is also rejected, this one is automatically rejected. So the only option left is under root 5 by 3, because if you move on, it is 1 more than 1 and less than 3, which satisfy if I add on 1 and 1 in both these. I means my answer of this alpha square set reaches a particular set whose value is closer to this. Okay, that is what I meant. Okay, so what I did, let me make you understand. This question is means quite a complicated type question. Okay, what I did nothing but, okay, let me make you understand. Let me get the page. Okay, so what I did, when I considered this set, okay, this set, I get a R value. Okay, fine. Okay, which was belonging from 1 minus under root 5 to 2 to 1 plus under root 5 to 2. Okay, then I got a second set value. Okay, are belonging from minus infinity to where is that set? Okay, I got a next set which was minus infinity to minus 1 minus under root 5 by 2 union 1 plus under root 5 by 2 minus to infinity. Okay, so we will take union, we will take intersection, while taking intersection we will get a R which is belonging to minus 1 plus under root 5 by 2, because it is negative and this is positive, 1 plus under root 5 by 2. So the possible value included between those two set is this, and 1 will be excluded, because if 1 is included then it will no longer be a GP. Okay, the sides of the triangle will become same. Okay, so we got this thing. When we got this thing, we know the alpha square. Okay, from the previous one, that is alpha square is what? Alpha square is R square plus R. Then we added 1 R and subtracted 1 R, 1 plus 2 R upon R square, and this equation satisfied. It cannot be 0. Okay, so it has possible R value belonging to this, it is satisfied. If I add that set plus 1 value, then I will get alpha square, new set value, complete set value. So I added, it is between greater than 1, okay, and it is less than 3. Okay, if you calculate under root 5, it is 1.2 plus 1 plus 1. Okay, so it will not be 3, it will be less than 3. Okay, 2 point or something, I don't have any idea of, this will be 2 point something like. Okay, but it will be less than 3. So that gives us a precise hit that this fourth option is the correct answer. Okay, now let's move on. This question was a J advanced level question. Okay, now let's move on to the next question. Okay, the next question is comprehension from comprehension 3. Okay, which is this question. Okay, let me get the page also. Okay, yes, this is comprehension. Okay, let me get the two options are also there. Okay, there are total 3 questions. Okay, from this. Okay, so the comprehension 3 is in a GP. The sum of the first and the last term is 66, and the product of the second and the last. Okay, last one. Okay, last one is 128, and the sum of the term is 126. Okay, so if I consider the terms in a GP, okay, then what is telling this? Okay, the GP, a plus an is what? A plus an is what? 66. So this is nothing but a plus a into r power n minus 1. This is what? 66. This is my one equation. In the next equation, what they, the product of the second and the last one. Okay, and the last one, it is what? Product of the second and the last one means, second means what? Second I can take ar into last means ar power n minus 1. If I put instead of n, I have to replace n minus 1, so I will get n minus 2 should be equals to what? 128. Okay, which gives us, okay, if I multiply r, this will be a square r power n minus 1 is equals to 128. R n power 1, a r power n minus 1, I can get this value by putting 128 by a. Okay, now I got it. I will put it to, I will put 2 value in 1, which will give me a plus 128 by a should be equals to 66. Okay, if I cross multiply, okay, which will give me a square minus 66 a plus 128 equals to 0, giving me a minus 2 into a minus 64 should be equal to 0. So a can be equal to 2 or a can be equal to 64. Fine. Now if we consider, okay, for a is equals to 2, okay, if I consider a is equals to 2, 2 plus 2 into r power n minus 1 should be equal to 66, giving me 1 plus r power n minus 1 should be equal to 33. Okay, which will give me r power n minus 1 is nothing but 32. Now for a is equals to 64, if I apply 64 plus 64 into r power n minus 1 is equals to 66, which will give me precise answer r 64 r power n minus 1 will be what? This will cancel out, giving me 2, which will be r power n minus will be nothing but 1 by 32. So here you can automatically guess that this is an increasing GP and this is a decreasing GP, because r value is opposite. Okay, not a decreasing GP, but means in infinite 1 r will become, so we write 1 by r power n like that. Okay, stuff. Okay, so you must have got that hint. Okay, now if I consider, okay, now first question, in an increasing GP is considered, then the number of terms in GP is, okay, in an increasing GP, so we want to find the number of terms. Okay, so for that s is equals to what? S is equals to it is infinite, no, it is number of terms. Okay, so 2 into, for a, because for a is equals to 2, we got an increasing GP, this is increasing GP, and this is what? Decreasing GP, whose a is what? Decreasing GP, whose a is what? 64. Okay, so 2 into 1 power r power n minus 1 upon 1 minus r. Okay, so we are getting what? If I take minus outside, sorry, this is increasing GP, so I have to write it r power n minus 1 upon r minus 1. Okay, so it will be what? 2 into r. Okay, s the sum is given, sum of number of terms is 126, so 126 into r minus 1. Okay, we can reduce our work. 126 is equals to 2 will cancel this will become 63 into r power n minus 1 upon r minus 1. This will become 63, r minus 63 is equals to r power n minus 1. Okay, so we are left with what stuff? This. So in this thing there is one manipulation which, if you are smart enough, then only you can predict. R into r power n minus 1, I can write this, and I know r n minus 1 value, which is 32 into r minus 1 is equals to 63, r minus 63, which gives us, if I subtract 63 r minus 32 r, gives me what? If I move this 62, so this will cancel out, giving me 31, r is equals to 62, r is equals to nothing but 2. So I got r is equals to 2 for increasing GP. Okay, so my r is equals to 2 for increasing GP. Now I know r power n minus 1 is equals to 32. I know my what? R, which is, so 2 power n minus 1 is equals to 2 power 5. 32 is what? 2 power 5. So n minus 1 is equals to 5, giving me n is equals to 6. So I know the number of terms also in the increasing GP. So can I get, okay, so the increasing GP, the number of terms in the GP is what? 6. Okay, so this is my answer, first passage solution. If the decreasing GP is considered, then the sum of the infinite terms. Okay, we want to find the sum of the infinite terms. For that, if I consider this sum is equals to what? In decreasing GP, 64 into 1 minus r power n upon 1 minus r. Now you will tell it is an infinite GP. Why we are doing this? Okay, so we are doing it because we are considering it as a GP now, for now, because there is in the it is a decreasing GP like that. Okay, so to get some, okay, let me check, because okay, check me again, let me check r power n minus 1. Okay, we are not doing any mistake now. 64 into 1 minus r power n. Okay, in decreasing GP. Okay, in a decreasing GP, sum of consider the sum of the infinite terms. Okay, we are getting the sum because the only way to find r is to use this summation series like we used that, because it can also be a sum of infinite increasing GP. To find the r, we have to do this thing. Okay, although they have told the increasing GP. Okay, but in this type of question you have to do it like we did in this. This gives us a hint that by using this I can get the r of this also. Okay, if you will do the imply the infinite series, then you will not get the r only. Okay, so this is, okay, if I apply this, okay, a is what? My 64. Okay, the sum of the terms, okay, either it is decreasing GP or increasing GP, it should be equal to 126. Okay, the sum of the terms, okay, they have not mentioned any GP, okay, increasing or decreasing, so sum of term will be automatically 126 only, which gives me another hint that if I cancel out this 32 into 1 minus r power n will be what, this will cancel out and this will be what, 62. Okay, this will be 63, yes, 63 into 1 minus r, giving me finally 32 minus 32 r power n, r power 1 into r power n minus 1 is equals to 63 minus 63 r. Finally what we are getting, that r power n minus 1 I can write it 1 by 32. This is what 32 only. Okay, and if I know r power n minus 1 for a decreasing GP is 1 by 32, so I will substitute 32 into 32 minus 1 by 32 into r is equals to 63 minus 63 r. Okay, this will cancel out, giving me minus r is equals to 63 minus 63 r. This will move here and this will move there, which will give me 62 r is equals to cancel out, giving me 31. Okay, this will be 1 by 2. So r is equals to 1 by 2 for a decreasing GP. Okay, the reason for doing it to get r, okay, like we did in the increasing GP, they have not mentioned anywhere that it is increasing or decreasing GP. They have told the sum is equals to 126, either it will be increasing GP or that is the smart sense, which mostly means smart children use. Okay, they don't understand the language, mostly means any children which will do, they have to understand the logical terms also, what the question actually want to mean. Okay, if you cannot understand that, I have to, if you will get stuck that I have to use infinite GP, then you cannot solve this. Okay, so I got that r is equals to 1 by 2. Can I get the sum of infinite terms? Yes, 64 upon 1 minus 1 by 2, which will be nothing but 64. This will become into 2, okay, which will be 126 only. Okay, r is equals to 1 by 2. Let me get the next page. Where is the next page? Next question is 64 into 2, 4 to z 6 to 2. Okay, it is 128. Okay, so this is second one. Okay, so 128 is the correct answer. Okay, so hope you have understand, okay, how we did that. Okay, now for the third option, in any case the difference of the least and the greatest term. Okay, so to find the least, smallest, we know the a is equals to 2. To find the smallest, Tn is equals to a means 2 plus bracket n means 6 minus 1 into d. Okay, it is a GP, sorry, it is a GP. So I know that a Tn will be a power r power n minus 1. The here 2 into r is what, 2 only, n minus 1 means 6 minus 1 means 5. This will be what, this will 2 32 64 only. Okay, so this will be 32 into 64. Okay, so by greatest term for an increasing is 64 and smallest term is 2. Okay, my r is 2, so I can predict the next terms easily. Okay, for the decreasing, my first term is 64. Now I have to find the Tn term. 64 into 1 by 2 power 6 minus 1. Okay, the number of term in both will be same only because they are same, but they are increasing and decreasing. 2 power 5, which will be nothing but 2. Okay, 32, this will become 2 power 5 will be what, 32. 32 will cancel out this by 2, so which my last term will be 2, and this will decrease on, this will become 62, and so on, it will decrease 1 by 2. Okay, so here what we are getting, okay, it will decrease, and what we are getting a general 6 term means 32, and so on, it will decrease. So what we are getting a general idea that how the term, this will be 8 2 2 2. Okay, so what we got, that the difference between the greatest and the least means 64 minus 2 is nothing but, okay, the difference of the least and the greatest is how much, 64 minus 2 means 62. Is there any 62 option? Okay, is there any 62 option? I think I have written the third option same only. Okay, third option I have written same only. Okay, it will be 62. Okay, it will be 62, it will be 62. Okay, so it is the correct, otherwise it will be none of this. Okay, so we got the answer, it is nothing but difference, means 64 minus 2. Here also the first term was this only, the difference will be same only. So hope you have understand the problem. Okay, it was means a good problem. Okay, using all the concept. Okay, I have to use this page because I am not used and did on the rough page. Okay, so the basic idea of how do you have to proceed this formula, how we did, we considered terms applied, we got an idea that I can substitute a power n 28 by a. Then by putting the value, I got again a quadratic. Then I got two possible a value, which indirectly given that two series can be possible. A is equals to 2. I got r power n minus 132, and for this I got 1 by 32, which suggests me that there will be two series increasing and decreasing GP. Then I applied s is equals to 2 into r power n minus 1 upon r minus 1. There I got n is equals to 6, which there I got r is equals to 2. Okay, then I got r is equals to 2, which helped me to find the n is equals to, so both the series will have 6 terms. Okay, and moreover, then I went for the decreasing GP. The reason for applying this formula instead of applying the increasing, infinite problems, infinite series summation, although the question I've asked. Okay, why I've put 126 here, the sum of, because they are both same series only, but they are in reverse, increasing and decreasing, the sum will be same only. That is the logic. Okay, then I applied that, I got the r, which again proved my what I was thinking in that direction, that it will be decreasing GP. Then I got all the terms. Okay, and then I proved what the question was asking. Okay, so we are done with the third comprehension. Now let's move on to the fourth. Okay, the fourth comprehension is as follows. 4 different integers form an increasing AP. One of these number is equal to the sum of the square of the other 3 numbers. Then first the product of all number is what? Okay, so here let the 4 numbers which are in AP, let be a minus d, a plus d, a plus d, and a plus 2d. Okay, you can take any number of terms, but what was the purpose taking, because they will cancel out. Okay, that is okay. Now what we can do, the any number term is equal to square of the other term, means a minus d the whole square plus a square plus a plus d the whole square. Now here 2ad and minus 2ad will cancel out, which will give me 3a square. 3a square, here d square, here d square, means 2d square. Okay, so here if I move this a plus 2d I have, which I move here, I get 3a square, 3a square plus 2d square. Okay, minus 2d minus a. So if I make a quadratic, okay, if I make a quadratic, if I get my d, then my problem will be solved. 2d minus 2d plus 3a square minus a. So it is a quadratic. Okay, now it is a quadratic. So can I get the d value? Yes, I can easily get the d value, which will be nothing but 2 plus minus under root. Okay, which will be 2 square, means 4 minus 4 into 2 into 3a square minus a upon 2 into 2, which will give me finally 1 by 2 into 1 plus minus under root 1 plus 2a minus 6a square. Okay, so I'm getting this value. Now let's take the next page, which if I take, I am getting d value as 1 by 2 bracket 1 plus minus under root 1 plus 2a minus 6a square. Okay, now what we can do, then the sum of the all number. Okay, product of all the number. Okay, they are what asking. Now if you observe, it is an increasing, so d should be positive. For d should be positive, this under root should be positive, so 1 plus 2a minus 6a square should be greater than 0, which gives me a hint that 6a square, my this one is term is negative, so I will make it positive. Minus 2a minus 1 should be less than 0. If I find a value, a is what, 2 plus minus under root 36 minus 4 into 6 into minus 1 by 2 into 6, which will give me a is equals to 2 plus minus, okay, under root this will be 36 plus 64 upon, okay, 64 upon 12, which will give me a is equals to 1 minus under root plus minus under root 6. Okay, so we are left with this thing. Okay, so what we can do, okay, now it is less than 0, so if I draw the wavy curve, 1 minus under root 7 by 6 and 1 plus under root 7 by 6, my answer will lie between this positive negative. So my a belongs to what? 1 minus under root 7 by 6 and 1 plus under root 7 by 6. Okay, so and now how we can get the a? Okay, is there? Okay, because if I consider it is not also this, so what value of a we can take? That is the problem here. Okay, the 4 different integers of an increasing. Okay, now a is also an integer, so okay, a is also a term, so it should be integer. A should be an integer, and it is integer. So only possible integer between two these is a is equals to 0. So if e is equals to 0, then can I get my d value? Okay, yes, we can easily get the d value by substituting it here. Okay, if I substitute here, I get d is equals to 2 will cancel, giving me d is equals to 1. Okay, I get d is equals to 1 or 0. Okay, d is equals to 0 is not possible only, then it will no longer be a AP. So we will, d cannot be equal to 0, so d is equals to 1. But remember in GP r is equals to 1 is not possible, or same 0 is equals to 0 also is not possible. So in AP d is equals to 1 is valid. So can I get the 4 terms? Yes, my first term will be what? This is 0 minus 1, this will be what? 1, this, okay, this one minus 1, 0, 1 and 2. So the product of all the terms is minus 1, 0, 0. Okay, third one is the correct. Now if I take the second question, which is telling sum of all 4 terms. So if I see the sum, minus 1 plus 1, 0, 2. So this is 2. If the decreasing GP is okay, we got the series only, that is a and d are the roots of AP. We got that, so there is very less chance of getting any answer wrong. Sum of the difference of the 4 terms. Okay, the common difference of the 4 terms is what is, okay, if a 0 minus 1 minus, okay, 0 minus into minus 1, which is nothing but 1. Okay, so and here also 2 minus 1 is 1. Okay, you can get from any 1 minus 0 is 1. So this is 1. So third also we are done with. Okay, hope you have understand what we did. We considered these terms, you can consider any terms, no matter. We consider positive, why consider these two? Because there is high probability that they will cancel, so my 2AD term will get removed. That was the logic behind doing that. Okay, then I multiplied, I considered a GP, means a quadratic in A. I could have considered it in A, no matter, I would have got D value. Okay, then I would substitute and get A value. Okay, doesn't matter, then I got the D value. After getting the D value, I know that D will be an integer. Okay, particular integer for an AP, and same goes for A. So I got my A is equals to 0. I put it in the formula, this formula. I got my D can be 2 values, 0 or 1. So D cannot be 0, because if it is 0, it will no longer be a AP. So D is equals to 1 is the only possible answer. Then we did what? Vivek curve also we drawed for getting A. Okay, after doing that, our last thing was getting the equation. We know that A and D are the roots, okay, of the AP. If I got that, I got the AP. So after these 3 questions were very simple. If they have asked some, then it would have been another scenario. Okay, so now let's move on to the last comprehension, which is this: consider the sequence in the form of groups. Okay, I have taken all the questions, right? Let me get the questions. Okay, I have considered all the questions, right? This comprehension has 3 questions also. Okay, this comprehension also has 3 questions. Consider the sequence in the form of groups 1, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 5, 5 times. Okay, the 20th term of the sequence is not divisible by. Okay, they are telling the 20th term is not divisible by sum of the 20th term. Okay, and the sum of the remaining terms in the group after 20th term in which 20th term lies is. Okay, now if you see, don't observe it like a group. If you observe this first term, this is second term, this is third term, this is fourth term, this is fifth term, and so on. This is fourth term, this is means like that. Okay, okay, now if I consider this in group, this is one group, this second group, 3, 3, third group, 4, 4 group. What was the purpose of doing it? There are 1 term, there are 2 term, there are 3 term, there are 4 term, in like 5 term, and it will go on n. Okay, in this type of pattern appears. I have told you, no matter what term they tell you, place it between the n minus 1 and n plus 1. Like the n minus 1 term, n into n plus 1 by 2, I will replace n by n minus 1. and what term I want? 2000 less than equal to n into n plus 1 by 2, the nth term. I will replace here n minus 1. Here if I replace n, I will get n only. Should be 2000 n into n plus 1, which will give me n square minus n 4000 n square plus n. Okay, so I got this thing. Okay, after getting this thing, what I can do is okay, now if I consider case 1, okay, let me get the next page. If I consider the case 1, which is what? N square minus n minus 4000 less than 0. N is what number? It will always be positive, so n will be what? 1 plus minus under root b square 1 minus minus plus 4 into 4000, okay, upon 2, which will be nothing but 1 plus minus under root this will 1 plus 6000 unit, okay, upon 2, which will give me 1 plus minus under root 16001 upon 2, and this is nothing but its approximate value. Okay, let me use a calculator. Okay, what is the okay, this its approximate value is 126 point something. Okay, so we can approximate it to 127. So this is nothing but 1 plus minus 126 127. If I take, then I get 127 plus 1 means 128 by 2. Okay, plus 1 only I will take, negative 1 I will not take, otherwise it will become negative, which I will not take. Positive is 128, which is nothing but 64. Okay, so n, okay, this will be what? N should be less than 0. Okay, which gives me what? N should be less than, okay, 64. Okay, so I got this from 1. Okay, n should be less than 64. In the next one, if I consider n into n plus 1, okay, into 4000, okay, this was less than equal to 0. Here it will be what? N square plus n minus 4000 is what? Greater than equal to 0, which will give me, here also I will get n is equals to what? Minus 1 plus minus under root 1 minus minus plus again 16000 upon 2 minus 1 plus minus under root 16001 upon 2. If I approximate, minus 1 plus minus 126, okay, 127 I will take again by 2. If I approximate, I get 126. I will consider the positive 1 by 2, I get 63. So n, okay, n should be what? N should be greater than, okay, here greater than equal to what? 63. Okay, so we are getting n greater than equal to 63, and from case 2 we are getting less than greater than equal to 63, and it is telling less than 64. So n is equals to 63. So the 28,000 term lies in 63 group. Okay, fine. Now we can do what? Okay, so our next job is to find what sum of the remaining terms in the group of, and so before that, how many terms comes, that we need to find out. So terms till group is what? How we can get that? The terms are 1 2 3 like that. First group was 1 term, second group has two terms twice, 3 terms, okay, like that till 62. It will be nothing but 62 into n plus 1, n into n plus 1 by 2 we will apply, which will give me 62 into 63 by 2, which will be nothing but we will get what? Let me use calculator. 1953. Okay, so we are getting this value. Okay, so we got this value. Okay, so we got the terms before. Now if I want to get the sum till 20,000 term, okay, now the 20,000 term is what? It is in 63 group, means there is some 63 group, there is in between there is one term which is 20,000th term, if we consider 1 2 3 4 like that. Okay, so that is the main idea of this type of questions. Okay, so in between there it is lying, and before that it is 119,503. Now if you observe clearly by sharp observation, you can guess this 1 2 2, okay, group 3 3 3 4 4 4 4. Okay, if I want to get the sum till to 20,000, okay, this I can write at 1 square. This will be 2 plus 4. This I can write as 2 square. This will be 9 3 square. This will be what? 4 plus 4 8, 8 plus 12 16, so 4 square, and so on. I can write it 62 square. In the 63 group, how many terms are that? So I want to know till 20,000 term. Okay, and before that it is what? Before that 63 term are what? 9 19 5 3. Now listen, what is How we got that? Till 62 group I have this number of terms. In the this 20,000 term, in the 63 group, the 2,000 terms arrive somewhere like this, and I know this is 1953 term, and I know the total it is 20,000 term. So if I remove this, okay, 20,000 term, from 20,000 if I remove this number of term, I will get the 63 groups term. Okay, how many groups are means terms are there in the 63 groups? Okay, till it reaches this 20,000 term. So my final answer will be what? Here I will apply n into means 62 into 62 plus 1 into 2 times 62, 2 times 62 plus 1 by 6 plus 63 into this will be what? This will be 47, which will give me my final answer as 84336. Now in the third option, what they are asking, sum of the remaining terms in the group of 20,000. Now this is 63 groups. Okay, this is 63 group. It would have some terms. Okay, in between 20,000 terms are arriving. I got that here 47 terms are there by this. So here how many remaining terms are there? How we can get that? Okay, it means it is not that much. Okay, there are means in the 63 group, okay, there are 47 terms here. Total 63 terms are there. In 62 there will be 63 group terms. 63 group there will be 63 terms. 47 are there. Then how many left terms are? So 63 minus 47, which will give you nothing but 16. So how many terms are there? Okay, the sum. How we got the sum? We got the sum by multiplying number of terms in the group into that group. Okay, number of terms into that group, which is 63 group. So here 63 group, how many number of terms are there? 16, which if I multiply I have 1008. Okay, now let's see the first question. Okay, although I have targeted the by question only. Okay, the first question was the 20th term of the series is not divisible by the 20th term of the series. Okay, the 20th term, the 20,000 term of the sequence is not divisible by what? Is not means divisible by. Okay, is divisible by what? Is not divisible by what? Okay, the 20,000 term was what? The 20,000 term. Okay, the 20,000 term in 63 group. Okay, in 63 group, it is not okay. So the 20,000 term is 63 group, means it is 63. Okay, so 63 is divisible. Okay, it is divisible by 3 also. 63 is divisible by 3, 9 and 7 also. Okay, so 7, 9 is 63. Okay, so with not divisible means fourth is the answer. Okay, now second, sum of the first 20,000 terms. Okay, we got that it was 84336. And the last question, in any case, okay, not this one. Okay, the sum of the remaining terms in the group of 20,000 term in which 20,000 terms lies. Okay, the remaining terms. Okay, we also found that which was equal to what? Which was equal to 1008. Okay, 1008. Okay, so this was answer. So we are done with 5 comprehensions, and we will continue it in the rest of the comprehension in the next lecture. Till then, continue, and we are very close to wind up the series and progression section and move to the inequality part of the means AM greater than GM, that type of questions in the sequence and series. So take care, see you, bye.